Okay guys, in this video I'm going to re-show you guys how to calculate the theoretical yield if you have a given reaction. This video you can watch if you haven't had time to come in and get help after school and you are planning on retaking your reactions unit written exam and or lab exam. You also have to be able to determine a theoretical yield for the acid and base test as well, and you will have to know who a limiting reactant is and all that stuff too. So this is just kind of good review in general, even if you're not retaking the test. So I kind of made up like a hypothetical situation here, and I'm going to be looking at this double displacement reaction between barium chloride and sodium sulfate. So this double displacement reaction happened. I ended up with these two products on the right side. And like we learned in class, a double displacement reaction, the only true product is the solid one. So I don't care about the sodium chloride that I formed over here. I only care about the barium sulfate because that is my product that's solid. So that will be the one that precipitates out of solution, right? That's that solid precipitate that you make. That's the one that we care about. So I'm just going to highlight it just so we remember, right? When we go to do the yield, what we care about at the end of the day is how much barium sulfate we're actually making, because that's what theoretical yield is, right? It's how much product should we theoretically be able to make, assuming nothing goes wrong, if you're given, right, this amount of each reactant, right? So assuming, again, nothing goes wrong, if I have 2.5 grams of barium chloride and 2.95 grams of sodium sulfate, right, those numbers here, right, how much barium sulfate should I theoretically be able to make, assuming nothing goes wrong? So the first step in finding out what the theoretical yield would be is we first have to find who the limiting reactant is. And I'm going to kind of review that example real quick I gave in class with the car frames and the tires. So I already have this little paper already made up. But the one I did in class was, okay, let's assume that we have 4 car frames here, excuse me, and 32 tires, right? And you work at a car factory, and we know that 4 tires go on every 1 car frame. So if you were on the production line and you only had 4 frames and 32 tires, right, what would our theoretical yield be? So assuming nothing goes wrong, right, how many finished cars should we be able to make, assuming nothing goes wrong with the 2 starting amounts that we have for our reactants, right? And as you guys were able to figure out pretty easily, we'd only be able to make 4 finished cars. And that's because our car frames ran out first. It didn't matter if we had extra tires here. It didn't matter if I gave you 200 tires or 10 million tires or 100 million tires. The amount of tires wasn't going to help us if we didn't have any more frames, right? So it doesn't matter how much excess we have. The fact that we run out of these 4 frames first was what was determining how much product we were going to make, right? Our limiting reactant, how we defined it in class, that's the reactant that runs out first, right? It determines the amount of product that you make because, like we see here, once this limiting reactant ran out, our production stopped. It doesn't matter how much excess we have, right? That limiting reactant, it's going to be 100% used up, and that's going to determine how many final products that we were able to make. So I will actually take a screenshot of this paper here, just in case anybody wants to look at that a little bit later. But that is the same example that we did in class. So we have to figure out who's limiting in this chemical equation. So yeah, we're not dealing with car frames and tires. However, like the idea is still there, right? One of these chemicals is my car frames and one of them is my tires. We have to figure out, well, which one is limiting. So if using the same example I just did, our car frames are limiting. We have to figure out pretty much which one of these is our car frames, right? Which one is running out first. And then we have to know who the excess reactant is. And it won't matter how much of the excess we have, because if it's an excess, just like it didn't help us if I gave you 10 million tires, it's not going to help if I give you more excess reactant. So the amount of barium sulfate we are going to make is going to be solely dependent on who the limiting reactant is and how much of it we have. So I'm going to do the gram to gram method right now, and I might here in a minute show the molar ratio comparison method too. Just one thing to keep in mind though, when I go to do the gram to gram method now, it's the same thing or the same math that people are doing when they do the molar ratio comparison way. It's just the gram to gram way does kind of everything in one big step, and you have to be able to interpret the results of that calculation. The molar ratio way, it's a little more tedious to do. There's a lot of like little steps and thinking you have to do with each step. It's just easier to interpret those results, and you're less likely to make a mistake. So like the one I'm going to do now, my gram to gram method, this is the one where it's the math is a little bit easier. It's just harder for kids to interpret the result. So I'm gonna kind of show both ways on here. So I'm doing this gram to gram method here. I'll move this over so I can write with my right hand. So in the gram to gram method, what we have to do is you have to convert the grams of one of your reactants to grams of the other reactant. It doesn't matter which one you choose first. We can convert from barium chloride to sodium sulfate, or we can go from sodium sulfate. So I'm going to start with barium chloride and convert it to sodium sulfate, just because this one's written on the left and this one's on the right. So I'm just going to go left to right. I'm going to convert barium chloride to sodium sulfate. So in order to do this, right, gram to gram, we have to convert grams of one reactant to grams of the other reactant. And what this calculation is going to tell us is, hey, this much of this reactant is going to require this much of the other reactant in order for it to go to completion. Then we're going to be able to look at the amount that I gave you, and we'll be able to determine, do we have enough of the other reactant or do we have too much of it? And that's going to help us determine who's limiting or not. So I'm going to convert barium chloride to sodium sulfate. So the amount that was given to me of barium chloride is 2.5 grams. So I'm going to start with 2.5 grams of barium chloride, and I'm going to convert it all the way to grams of sodium sulfate. So that's going to require like a 3-step conversion, because I have to go from grams to moles, moles to moles, and then moles back to grams in my 3rd step. But when all is said and done, I'm going to want to end with grams of sodium sulfate, because again, I'm trying to convert from grams of one reactant to grams of the other reactant. My 2 reactants are barium chloride, sodium sulfate, so I'm converting from grams of barium chloride that I was given to sodium sulfate, and this is going to tell me how much sodium sulfate I would need in order to react all of this barium chloride. So our first step is going from grams to moles. So I'm starting off with grams over here in the numerator, so I'm going to want to have grams of barium chloride down there at the bottom so that I can actually eliminate that unit. So I need to figure out then, for every 1 mole of barium chloride, how many grams of barium chloride is that? You don't know that off the top of your head. You will have to use the periodic table to find that. But what you have to do is you have to go to the periodic table and look at the molar mass of barium and 2 chlorines and add it together. So I've done that already for you here. I will also screenshot this so that you guys could also have this to look back at. But the work that we do for that, right, if I'm looking at barium chloride and I have to get its molar mass, I look at the formula, I see that I have 1 barium, 2 chlorines. So I go to my periodic table and I see that barium is 137.33. I have to take chlorine's molar mass times 2 because there's 2 chlorines in my formula. Chlorine's molar mass is 35.45. I multiply it by 2 to give me 70.9. I have to add these 2 together. So I kind of did like an addition here of this and this in order to get my 208.23. So that's how many grams I have per mole of barium chloride. So I can make 2 unit conversion factors with that. That means that I have 208.23 grams of barium chloride for every 1 mole of it. Or we could just flip that and say the same thing. For every 1 mole of barium chloride, I have 208.23 grams. I guess I'll just skip ahead right now, but I also had to figure it out for sodium sulfate because I'll need that in a minute. So I looked at this formula and I see that I have 2 sodiums, 1 sulfur, 4 oxygens. So I go to my periodic table, right? I found sodium's molar mass, times it by 2. Sulfur's molar mass, I only had 1 of them there. Oxygen, I have 4 of them according to my formula. So I looked up oxygen's molar mass, which is 15.999, multiplied it by 4 and got the 63.996. I added all of those numbers together to get the 142.036. So that's how many grams I have for every 1 mole of sodium sulfate. So So again, here are the two unit conversion factors that I can create with that information. So I'm going to go back to the problem I was just working on. We were trying to figure out the molar mass of barium chloride, so how many moles we have for every 1 gram of it. And I know that, again, I have 208.23 grams for every 1 mole. But if I go back to my problem here, right, I have to decide, am I going to multiply, right, this first number here, this factor that I'm putting here, and am I going to want to use this one or this one? Saying the same thing, I'm just writing it a different way. Well, like we just talked about, we want grams on the bottom of that denominator so that they can cancel out. So I'm going to want to use this bottom one here because this is the unit conversion factor that represents that relationship but has grams on the bottom. So I'm going to go here and write that same number we just calculated for that molar mass. I have 208.23 grams for every 1 mole of that stuff. So now we're in moles of barium chloride, but right, we're not done yet because we're trying to get to grams of sodium sulfate. So the next thing I have to do is figure out, well, how many moles of barium chloride, right, react with how many moles of the sodium sulfate, right? What is the ratio that they react in according to this chemical equation? So without even looking up here at the top first, I know for a fact before I even look up there that I have to have moles of barium chloride here on the bottom because I want those to cancel out, right? So up here, I'm going to have my moles of my sodium sulfate up here. So this number right here, this, I should say this conversion factor, excuse me, right here, I get these numbers from the chemical equation itself, right? The numbers I'm going to put out in front here are the same numbers that are in the chemical equation. And I already have this balanced out for us. So this was like a 1, 1, 1, 2. So technically that means that for every 1 mole of barium chloride, I need 1 mole of the sodium sulfate. So I look, the number out in front of here is technically really a 1. I'll kind of add those in here for you. I have 1 mole of barium chloride for every 1 mole of sodium sulfate. So you would straight up just come right up here, look at the numbers that are out in front of your reactants and put them here. Just make sure that you're putting the number, like the bottom is barium chloride, so write the number that's in front of the barium chloride. And when this one's sodium sulfate, make sure you're writing the number in front of the sodium sulfate. This example works out nice because they're 1 and 1. Other times, right, you might have a 2 to 3. So making sure that you're actually writing it the correct way. Is it 2 to 3 or 3 to 2, right? It really kind of matters. So make sure that you're just writing the number directly in front of that chemical, okay? So now I've got rid of my moles of barium chloride, right? And I'm left with moles of sodium sulfate, but that's not my final answer. I have to convert that to grams. So I have to figure out for every 1 mole of sodium sulfate, and I'm putting moles of sodium sulfate on the bottom so they go away, I have to figure out how many grams of sodium sulfate that is. And if you remember just a second ago, I kind of went through here and explained, right, how to find that molar mass of sodium sulfate, and we know that it is 142.036 grams. In this case, though, we have to decide, right, do I want to use this unit conversion factor on the top, or do I want to use the one on the bottom here? Well, if I look at this equation I'm doing, I need moles on the bottom and grams on the top in order to finish this, finish that part of the calculation. So I'm going to choose this one here I made on top that has the 142.036 grams of that there on top. So now we're done. We're ready to calculate. Obviously, my answer is going to be in grams of sodium sulfate, because if you look at this, right, the only unit I have not canceled out, right, all these units have canceled except for grams of sodium sulfate. So that makes sense that my answer is going to be in grams of sodium sulfate, right? So then that's how you know that you have fully converted over to the other reactant. So I'm just going to type this straight into my calculator, right? I'm going to type in everything in the numerator, hit enter, and then I'm going to divide it by the product of everything in the denominator. So I have 2.50 times 1 times 1. So I'm not going to bother writing that in my calculator because I know what that's going to equal. But I do have a times 142.036 there on the numerator. So I'm going to hit enter. That equals 355.09. I have to divide it by everything in the denominator. So I'm going to put parentheses around it because in case some of these numbers weren't ones, like if you had like 208.23 and this was a 2 and that was something else, or that would be a 1. But either way, you want to make sure that you have parentheses around the thing in your denominator so that your calculator knows that you're dividing that number by the product of everything in the denominator. So I have 208.23 in the denominator, and then technically we have times 1 again, so I'm not even going to bother with that. But I'm going to go ahead and type that into my calculator, and it's telling me 1.705277818. We're limited to 3 sig figs though, because the amount I'm given in the beginning, this measurement here, is only 3 sig figs good. So what I'm doing now is just a conversion. So if I only have 3 sig figs to start with, I'm converting it and just saying it a different way. I have to stay true to the accuracy of that measurement. So if I have 3 sig figs here to start, I have to have 3 sig figs in my final answer. So I have to round this to 1.71 grams, okay? So this is what this tells us. So we just did the calculation, but it's really important that you guys understand what this actually means. So what this tells us is if 2.50 grams of barium chloride, like, were to fully react, it needs 1.71 grams of sodium sulfate, right? So 2.50 grams of barium chloride requires 1.71 grams of sodium sulfate in order to fully react. Well, now we have to look at, well, did she give me this much? Do I have as much sodium sulfate as I need? So I'm going to come back up and look at how much I was given. I was told that I was given 2.95 grams of sodium sulfate, right? So I have way more than I need, right? I only need 1.71 to fully do this reaction, but I was given 2.95, right? So I'm going to put, I have 2.95 grams of sodium sulfate, which means I have too much sodium sulfate. And if we have too much of that reactant, that means that it's an excess. So therefore, I'm able to determine that the Na2SO4 is in excess. So that is my excess reactant. So I'd be able to come up here and actually say, okay, I just did the math to find out that this is my excess reactant, and this is my limiting reactant. So again, 2.50 grams requires 1.71 grams of the other one. I have 2.95 grams of it, so I have plenty. I actually have too much, right? This is kind of like the example with the tires, right? We had way more tires than we needed, and it wasn't going to help us at all. We weren't going to be able to make any more cars with extra tires. In this case, right, having all that extra sodium sulfate is not going to help our situation, right? Our barium chloride is going to run out first, and once it runs out, production stops. So we're going to be able to now look at how much barium sulfate are we going to make now that we know that we're going to fully use up 2.5 grams of barium chloride. So I'm going to start that next part next. I will make a little note here just to remind you guys that this first conversion factor here, I get from the periodic table. That conversion factor I got there was from the chemical equation. And this last number here is from the periodic table as well. So now that we know who the limiting reactant is, we are allowed to start step 2. Okay, so now I'm starting the step 2, which is the last step in the problem we're doing, which is now we can actually get the theoretical yield because that's what I asked for. Right, so step 1, we had to first figure out who's limiting, right, because that was going to depend on how much product we made. And now that I know who's limiting, now I can come down here and get the theoretical yield. So to get the theoretical yield, we have to convert from grams of the limiting reactant to grams of the solid product. So I have to convert from grams of my limiting reactant. My limiting reactant, we just found out, was my barium chloride. And how much of that did I give you? Well, if you remember, I gave you 2.50 grams of that barium chloride. So I'm going to come down here and start this calculation. Right, I have 2.50 grams of barium chloride. And I'm going to convert it all the way to grams of, who's my solid product? It's barium sulfate here. That's what matters. So I'm going to do a 3-step conversion just like I did up here, right? So I need grams of barium chloride on the bottom and 1 mole of it on top. And again, from the periodic table, I found out that I had 208.23 grams of barium chloride for every 1 mole of barium chloride. And again, that's what I found, right, when I did this step here. Now I come over to my chemical equation. For every 1 mole of barium chloride, I produce 1 mole of barium sulfate. So I want barium chloride on the bottom, though, so that my barium chloride moles can go away. And I'm writing the number that's directly out in front, right? I have a 1 in front of barium chloride, hence the 1 here. I have a 1 in front of the barium sulfate, hence the 1 here, right? And now I have to convert this over to grams. So I go to my periodic table, and for every 1 mole of barium sulfate, how many grams of barium sulfate is that? And just like I walked you guys through over here, right, you would go to the periodic table and look at the molar mass of 1 barium with 1 sulfur and 4 oxygens. I didn't do that one beforehand. I'm pretty certain, though, barium sulfate would be 233.386. I'm actually pretty certain on that one. Somebody can fact check me if you want, though. Okay, sorry, that looks really messy, but in case you didn't hear me, that would be 233.386. So now I'm ready just to type this guy right into my calculator. I'm going to go straight across. So I have 2.50 times 1 times 1, so I'm not going to bother putting that in, times 233.386. I'm going to hit enter, and I'm going to divide it by everything in my denominator, which is 208.23 times 1, so that's essentially just dividing it by 208.23. Again, I'm still able to have 3 significant figures. My calculator is telling me 2.80202, blah, blah, blah. So that's going to limit me to 2.80 grams of that barium sulfate. So this here, this is my theoretical yield. So what this means from kind of start to finish, if I were to give you 2.5 grams of barium chloride and 2.95 grams of the sodium sulfate, assuming nothing went wrong when you actually reacted them and retrieved that product, you would expect 2.80 grams of barium sulfate to have formed. So again, if I gave you those amounts, right, barium chloride ran out first, so that amount of barium chloride was directly affecting this. But what this means is when you do this reaction, when all is said and done, this should be the mass left over in your evaporation dish, right? If nothing went wrong, the 2 amounts that I gave you for both of the products should give you 2.80 grams of that product, right? That's what we care about. That's our theoretical yield, how much it should be. This is what the mass in your dish, again, should be. And then, of course, in the lab, you went through and actually reacted these things, right? You made the solid precipitate, you filtered it out, you rinsed it really well, you put it in an evaporation dish, and you dried it over a Bunsen burner, right? And that was your actual yield that you actually got during the lab, right? So theoretically, this is what you should get, and when we go back and compare that to what you actually get in the lab, and that's what gives us that percent yield. When we would take that percentage of our actual yield, what we got, divided by theoretically what we should get, and that gives us a percentage for how accurate we were, right? Our percent yield should be about 100%, right? If you're supposed to get 2.80 grams, we want you to get 2.80 grams in the lab too, to give you 100% yield and no error.